The last type of rigid transformation that we need to take a look at is rotations. Rotations is when we rotate an object about a fixed point. In this particular unit, we will be looking at three types of rotations. We'll be looking at 90-degree rotations, 180-degree rotations, and 270-degree rotations. Now, in mathematics, the normal direction of rotation is counterclockwise. This is the normal way that we rotate in mathematics. And so one of the things that I want to quickly point out is that if I have a particular point and I'm going to rotate it 90 degrees counterclockwise, which is the normal direction in mathematics, that is the equivalent of rotating that point 270 degrees clockwise. So, in other words, what I'm trying to say is that a 90 degrees counterclockwise rotation is the same thing as a 270 degree clockwise rotation. So then it stands to reason that a 270 degrees counterclockwise rotation is going to be the same thing as a 90 degrees counterclockwise or clockwise rotation. And then obviously if we look at rotating something 180 degrees, it doesn't matter which way we go. 180 degrees is halfway around a circle. It doesn't matter which direction you go, you're going to end up at the same location. It's important to understand this for these two particular directions, that so that when you get into the actual rules, you understand which rule you are using when it comes to rotations. Okay, so let's take a look at a particular rotation. Here I have a polygon on the coordinate grid, and we need to rotate this particular image 90 degrees about the origin. So the origin here is going to be my fixed point of rotation, and I need to rotate it 90 degrees. So I'm not given a direction. So in mathematics, the normal direction is counterclockwise. So that means that I have to rotate it this particular direction. So I'm just going to put counterclockwise here. And I know that I have to rotate each one of these points 90 degrees. Well, in looking at this particular image here, I know that if I look right quick like at point B lies here on the x-axis. The x and y axis are perpendicular to each other. If I rotate point B 90 degrees, I know my B prime is going to be up here. Okay, that point is really easy to figure out. So up here is going to be my B prime. Well, I can do similar things with K and Y. If I look at K and Y, I need to rotate 90 degrees. So, how am I going to figure out which way they go? Well, I could draw in a line and use a protractor and come up with the 90 degree perpendicular line to be able to find my K, but that could get really cumbersome. Or I could use rules. And you'll find that with rotations, that in this particular unit, memorizing the rules or using the rules is going to be the easiest way of doing this. So let's take a look at the rotation rule for a 90 degree rotation. The rule states that a 90 degree rotation is a transformation of the xy coordinates so that we have a negative yx. Okay, so what this means is that it means that the y coordinate is being negated and being placed in the x position, and the x coordinate is being left alone and placed in the y position. So if I take a look at these points individually, we notice that y is at the coordinate 4, 3. So if I input 4, 3 into that rule, my y prime then is going to be at negative 3, 4. So I come over negative 3, 1, 2, 3, 1, 2, 3, 4. So here is my y prime. Do the same thing with k. K is at the point 5, 3. So that means my k prime is going to be at negative 3, 5. So negative 3, 5. So here's k prime. And if you remember right, that's about where I had eyeballed that 90-degree angle. Okay, so let's take a look at B. B is at the point 5, 0. So that means that B prime then is going to be at 0. We can't negate 0. 0 is just 0. So you can't negate 0. So B prime is going to be at 0, 5. So 0, 5 puts us up there. So there's B prime. And then we have U. And U is at the coordinate 2, negative 2. So then U prime is going to put us at a 2, negative, or 2, 2, excuse me, 2, 2. So 2, 2 is here. So that's U prime. So then I can connect the points. And there's my image. My image has rotated 90 degrees about the origin. And here is my rule. Okay, so let's compare this with rotating 270 degrees. So if I was to, let's get some of this stuff out of our way here. If I was to rotate this 270 degrees, clockwise, then that means that I would have to rotate it this way. Okay? Well, a rotation of 270 degrees clockwise would give me a rule of 270 clockwise would transform my xy so that I would have negative y x. The rule is going to be the same. So if the rule is going to be the same, then it makes sense then that my points are going to end up in the exact same spot. But what happens if we just rotate it 270 degrees? Normal rotation. Well, then that changes my rule then. My rule then would be my rule then is going to be a rotation of 270 degrees where xy gets transformed to y negative x. So then that means that I have to take each one of these points and transform them. So I'll start with u. U we know is at 2, negative 2. So I plug that in. Then my u prime is going to, my y goes to x. So that's -2, and then I negate x and put it in y. So that puts me at -2, -2, -2, -2. So there's u prime. B is at 5, 0. So B prime is going to be at 0, -5. So 0, -5. Here's going to be B prime. Then we got K, which is at 5, 3. So K prime is going to be at 3, -5. So 1, 2, 3, -5. So here is my K prime. And then we got Y, which was at 4, 3. So Y prime then becomes at 3, -4. So 3, -4. So here's Y prime. Connect my dots here. And there's my image. So I have rotated 270 degrees about the origin. And there is my new image. Okay, so hopefully this helps explain rotations a little bit for you. I think after doing that, now you can quickly see that if I rotate 90 degrees clockwise, that is the same as rotating 270 degrees counterclockwise. If I rotate 270 degrees clockwise, that's the same thing as 90 degrees counterclockwise, and vice versa. So you have to pay real close attention to which way you're rotating to make sure that you use the correct rule. If you have any questions, give a shout out to me in Teams. Have a good day.